A very good morning to the examiners and my supervisor. I am Leong Fei Yee from 3SUSP Bioinformatics. My supervisor is Puan Havanya and co-supervisor is Dr. Hasbina. In this video, I will explain about the work and result that I have done for PSM1. The field for my PSM is on system development. The title of my project is Dental Decision Support System for Classifying Malocclusion using Convolutional Neural Network. This is the content that I'm going to explain later. There is a total of 5 chapters. In chapter 1, I will start with the introduction of malocclusion. The word malocclusion is derived from the occlusion, and the prefix mal is added to define the abnormal condition of teeth relation. In general, malocclusion is used to describe the imperfect positioning of the teeth when jaws are closed. Diagnosis of malocclusion is done through dental X-ray examination. It classifies into 3 types of condition, which is stated on the diagram at the left-hand side. Malocclusion can be fixed by placing braces, but it still depends on the skeletal structure of the patient. DSS stands for Decision Support System. The pyramid shows that a malocclusion classification DSS is a combination of image-based DSS and machine learning algorithm. DSS is information-based system that aid in decision making. An information-based DSS is capable to perform image recognition and classification by using a machine learning engine. Deep learning is a subset of machine learning. It has good performance in processing complex biomedical data. The use of multiple layers for features extraction has replaced the traditional method. One of the commonly used deep learning algorithms in image processing is CNN. There are 2 problem statements for the project. First one is the issue of increasing fake dentist cases due to lack of persuasiveness in diagnosis of genie dentists. Fake dentists conduct braces treatment without professional diagnosis. This will cause braces false placing, which will bring great side effect to the patient. For example, like teeth loose. Second, there are no existing software for malocclusion classification right now. The currently used method is based on dentist observations, which is difficult in providing supportive data. Regarding these 2 issues, a decision support system for malocclusion classification is proposed as solution. The aim of the project is to develop a decision support system for orthodontists in classifying malocclusion by using deep learning before giving treatment to patients. While there are 2 importance for the project. First, develop a system that can compare and identify the type of malocclusion of the patient, and second, help orthodontists in decision making by referring to the result of classification. The project has 3 objectives. First is to identify the best convolutional neural network architecture for malocclusion classification using cephalometric X-ray images. Second, to develop a system for analysis of shape of malocclusion and its variation in 2D visualization by using CNN. And the last one, to evaluate the proposed system in the real orthodontist field. The scope for the project is as follows. First, the dataset used for the project is cephalometric X-ray images, which is obtained from Faculty of Dentistry, UITM. This dataset only involves Malay races. Lastly, the system able to analyze the variations of malocclusion using CNN classifier. Next, we will continue with Chapter 2. Chapter 2 is a summary of all the research papers that I have reviewed. The summary is distributed into 4 subtopics. First subtopic is about the malocclusion classification method and cephalometric X-rays. Malocclusion has various classification methods. The one that used by the Faculty of Dentistry UITM is PSI, British Standard Institute Incisor. PSI has 3 main classes, class 1, 2, and 3. This method focuses on maxillary and mandibular incisor relationship. Incisor is the 4 front teeth for both upper and lower jaws. Class 1 for PSI is near to normal condition, means healthy teeth. Class 2 named as overbite, which the upper incisor is prominent, while Class 3 named as underbite, which the prominent side is the lower incisor. From the diagram, we can see that the Class 2 has 2 divisions. Unfortunately, these divisions are not able to classify using only the 2D X-rays. Therefore, they are not involved in this project. PSI is high dependability, since that the posterior teeth did not influence and in conflict with the incisor occlusion. Cephalometric X-ray is the input data for this project. Ceph X-ray able to indicate the side view of the face. It is used for the study of facial bone and soft tissue landmarks. To identify malocclusion classes, visual examinations and bite impressions is conducted on Ceph X-ray. PSS is a computerized program for providing support in determinations and judgment for action in an organization. It collects and analyzes data, after that produce an information report that include clauses and solution suggestions. There are some existing DSS which is purposely designed for image classification with different type of biomedical images and classification engine. The commonly used engines are neural network, k-nearest neighbor, naive Bayes, support vector machine, and so on. SDLC stands for System Development Life Cycle. It is the project management model that describes the phases involved in driving a project in order to reduce time consumed and assure quality of the system. There are three common methods have been reviewed. Their pros and cons have been listed clearly in the table. Waterfall model is linear sequential, which stages is clearly defined and easy to understand, but it is poor for complex and object-oriented projects. Agile model is flexible and suitable for changing environment, but it needs rapid customer interaction to keep track user requirements. Iterative models good for problem detection and resolving, but it is time and resources consuming. To decide which model to be used is greatly dependent on the project characteristic. In this slide, SVM, CNN, and RF algorithm will be discussed. The table has listed down about the definition, theory, tuning method, pros and cons of each algorithm. Since three of them are common machine learning algorithms which familiar to us, I will only focus on the pros and cons of each algorithm. SVM is simple and suitable for large dataset, but its results depends on feature selection done. CNN is good in reduced data pre-processing step, since it does not need feature selection. It has also well-known net with great performance, but it is not suitable for unlabeled dataset. RF is good for large dataset and is outperformed with text input data, but is not commonly used in imagery classification. In summary, three of them have their own strength in different fields, but obviously we can see that CNN has its strength on combining feature selection and classification in one learning framework. Now we have reached Chapter 3. Chapter 3 is about methodology justification. SDLC model that I have decided for the project is waterfall model. Waterfall model contains mainly 5 phases as shown in the figure. My PSM one is less complex and less specification. It has clear user requirements and the time range is short. So waterfall model is suitable for my project. Part 2 of Chapter 3 is about technologies used. Technologies used in the system include AI technology, website development technology, and lastly database technology. Software used during PSM1 is varied. For example, like Google Colab used for running code, Microsoft Word is used for documentation, and Draw.io is used for drawing various diagrams. System requirement analysis is distributed into two categories, which is software and hardware. For software, operating system needed are Windows 7 and above. While for hardware, components involved are input and output devices, 4 GB RAM and above, processor Intel i3 and above, and hard disk. The dataset used for this project is collected from Faculty of Dentistry UiTM. A total of 1,727 cephalometric X-ray images will be obtained. This number is the sample that can represent the Malay patient population. It is calculated using the proportion given by Faculty of Dentistry UiTM, and the population used is Malay population, which obtained from Jambatan Perangkaan, Malaysia. We are currently at Chapter 4 now. First part of Chapter 4 focus on algorithm performance comparison. SVM, CNN, and RF are the three algorithms used in this comparison part. Since I have not yet received the real dataset from UITM, chest X-ray images that obtained from Kaggle is chosen as the replacements. To obtain better simulation for the comparison, the dataset is modified to three classes with a total of 1,510 images. The ratio of image for each class is same as the real dataset. Only two steps of data preparation have been done, which is image resize and format conversion. No feature selection is done. Accuracy, precision, and recall is used for the performance measurement. From the table, we can see that SVM has the best performance among the others, while CNN performance is extremely low. It has a high training accuracy but low validation accuracy. This shows that the model is overfitting. The reason of causing overfitting might be the high complexity network architecture of the model. Because the model originally is designed for large dataset. The table shows the method on solving overfitting. There are increasing training data, do regularization, reduce classifiers complexity, and apply pre-built CNN-net. Part 2 of Chapter 4 is requirement analysis. It contains two components, which is functional and non-functional requirement. Functional requirements are illustrated through diagrams. This diagram is the class diagram of the system. There is a total of 6 classes. Two of them are superclass, named as Profile and Admin. Next diagram is the use case diagram. Use case diagram is a representation of users' interaction between the user and the different use cases. 5 functions are involved in the diagram. Admin is the user of the use case. Each of the functions are then illustrated using activity and sequence diagram. Diagram A is the sequence diagram for function edit profile. This is the database or interface involved in these functions, and this is the data flow between database and interface. Diagram B is the swim lanes activity diagram, which is able to show all the possible paths according to the user's options. In this diagram, there are 2 lanes named as system and admin, and 1 database. Square boxes represent the collections of actions, while the diamond represent the condition for next action. The system has 3 non-functional requirements. They are performance, usability, and compatibility. Performance is the system response time and classification accuracy. Usability is the degree of fitness of the system, which it can be tested by usability testing. Compatibility is the measure of the state which the system and its environment exist together without problems. System architecture that's used by this project is Model View Controller pattern. The system is structured into 3 logical components that interact with each other. Database acts as model component, which handles action done towards system data. User interface acts as view component, which is responsible in displaying information to user. The view and model components are connected by controller component. This component receives user interactions and passes them to view and model components. The diagram is logical entity relationship diagram. Dentist and student are the admin of the system. They're able to manage patient details like register patient and generate malocclusion report for patients. The data dictionary can be viewed in the PSM1 report appendix D. The system user interface will be displayed in this short video. Currently, the system roughly contains 8 interfaces. They are Register page, Login page, Home page, Users account page, List of patients, Register patient page, Patient details page, and lastly, Patient's report page. Chapter 5 focuses on objective achievement and future work planning. Objective 1 of the project is 50% done after the first round performance comparison between CNN, SVM, and RF. The second round comparison would be continued in PSM2 for final decision of algorithm use. While for Objective 2 and 3, both of them will be done in PSM2 because they are in the implementation phase. This is the Gantt chart for PSM2. The first two tasks has the priority to be started first to ensure smooth progression. First task is data pre-processing of the input images. Second task is the second round performance comparison of algorithm. After these two tasks are done, the rest will be focused on classifier and system development. After the system is completed, testing will be carried out for system evaluation, and then the last part will be the documentation of project. This table contains the research paper that I reviewed the most throughout the PSM1. That's all for me, thank you.